All right. Hi, my name is Abdul Martin, and this is my Emath assignment on hypothesis testing. All right, so let's begin. This is a statistics of weekly exercise times of students, and here is my link for my claim and my source, investigation of and statistics of students' weekly exercise time. So for my claim, on average, students exercise at least one time per week. Exercise one time per week. Then for my alternative hypothesis, on average, student exercise more than one time per week. So I have both my H0 and H1 equals to 1 and greater to 1 respectively. All right, so you can see here, there's a list of data for sample size of 30 for my students and the number of days each student exercises per week. So I have here my population mean being 1 from my claim of one time per week, and my population standard deviation being unknown because it's not given. So for my sample size, and I use the Excel formula count equals to count A1 to A31. Then for my sample mean, I use the formula average B2 to B31, and sample standard deviation being ST deviation dot S and B2 to B31. It's S because this is a sample size. All right, so for my significance level, it will be 0.05 being the 5%. And my test statistics for my t-test, the formula is here. So bracket F7 minus F3 over F8 over square root F6. All right, for my p-value, the formula is t distribution dot RT, then ABS F12, then F6 minus 1. All right. And for my margin of error, I just have confidence dot T, and F11, F8, and F6. For my lower confidence interval, it will be just the F7 minus F14. So down here and it's labeled down here as well. And for my upper confidence interval, I'll just put F7 plus F14. So it's down here as well. So from my observation, the p-value is less than the significance level, and hence it's sufficient evidence to accept the claim that on average, the student exercise one time per week. I use a t-test as there is no population standard deviation, and thus it's also a one-tailed test only. All right, thank you for listening and goodbye.